Good morning everyone. Today I'm going to say the topic on 3D position tracker. So let's go to the 3D position tracker. Before that we'll have a recap. So we'll have a technology and the description. So when we have the technology, the real environment has the physical world only. So that's the description. Whereas when we take as the augmented reality, it is the real world plus the virtual elements. And the mixed reality, the real objects which has the interaction with the other objects. And the virtual reality is that it is fully a virtual world. Now let's move on to what is a 3D position tracker. So when we come to 3D position tracker, a 3D position tracker is a system that determines the real-time position and orientation, which has a user device and also the object in a three-dimensional space. So that's called as the 3D position tracker. So when it determines the real-time position with the orientation and the dimensional space is that which is more useful, that is actually called as the 3D position tracker. Let's see this picture. This picture says how the 3D position tracker is taken place and how its real positions are being calculated. So here these are the roles that has been tracked through 3D positions in AR, VR as well as MR. So when we take AR, so the augmented reality, it has the align, it aligns the virtual objects with the real world. So this is how the roles of 3D tracking takes place. So in AR, VR and MR. So when it takes in AR, it aligns the virtual objects with the real world, and when it takes in MR, it enables the interaction between the real and the virtual objects. So when the performance and the parameters of 3D position trackers, how does it takes place and what are the parameters needed for a 3D position trackers is, the first is the accuracy and the precision, that is how it repeatedly takes place, latency, updated rate, the range in the covered area, the robustness, the drift. So this is how it takes place with the cost and the complexity. So these are the parameters for the 3D position trackers. So in this picture, you can see a person sitting and he is looking into the global. He wants to know what all the countries available are there in the earth. So when he is looking into it, the position is more needed with the range, the coverage area, and how much latency takes place and the updated rate. So these are the things they will be calculated in the 3D position trackers. So here we have the types of 3D trackers in AR, VR and MR. So when it takes an AR, here it has mechanical trackers, magnetic trackers, optical trackers, inertial trackers, acoustic trackers and hybrid trackers. So these are the different types of trackers which takes place with the mechanical trackers. The mechanical trackers has how all those trackers takes place in the mechanical way and also magnetic way when it connected with each other, and it has also have the hybrid trackers which connects with both optical and inertial trackers. So these are the tracking types, and it has a head tracking. For example, if you are tracking the head, what does that means it tracks the user's head movement. So when we are wearing it, and if suppose I'm doing like this, it will track how my head movements takes place and how does it works. Hand tracking, so it tracks the finger and the hand gestures, and also it tracks the eye, so how the eyes are gazing, whether it's gazing up and down or left and right, it depends on. And the body tracking, the full body motion is also captured through the body tracking. And object tracking, it also tracks the physical objects which moves on when the 3D animation takes place. So this is a quick comparison of how the 3D computer graphics, the virtual reality and the mixed reality takes place. So these are the applications of the 3D tracking. So it is the object placement, VR gaming and simulation. It is used in VR gaming, and also in medical navigation the 3D tracking is actually used. It is mainly used in the metaverse systems also. And here we have few limitations in the AR, and it says it is highly developed cost and device dependency. It also has some limited field of view because it is not well versed in today's world, and it has the performance and batteries also needed to watch. So these are the future scope for the AR MR applications. So you can look into the case study and go through the case study and have an observation. What does it says in the AR? So hope you all understood what is this case study tells about. It is the what are the solutions needed to demonstrate the AR. That is what is given here in the form of a 3D holographic arrows. So kindly look into it. Hope you all understood. Thank you.